Hello, and welcome to this presentation on human body model positioning using the Oasys LS-DYNA environment. So here is the outline of today's talk. First, we'll give you an overview of the occupant safety tools in the Oasys LS-DYNA environment. Then we'll move on and talk about simulation-based dummy positioning, and then how that can apply to human body model positioning. And then we'll summarize and wrap up. So for some background, I'll talk you through some of the occupant safety tools available in the Oasys LS-DYNA environment. So our tools provide a comprehensive solution for occupant safety applications using LS-DYNA. This includes creating seat mechanisms which allow you to easily move your seat into different positions. We also have tools for creation and fitting of seat belts. Our Seatsquash tool allows you to easily deform seat foam to remove initial penetrations between the occupant and the seat. Our dummy positioning tools allow you to position an occupant easily in a number of ways. Also note, we have a powerful airbag folding tool available as an optional plug-in to Primer, and this is called J-Fold. So here we have a summary of the tools. We've got seat mechanisms, which can be easily set up and allow you to move your seat around to various different positions. We then, of course, have seatbelt creation and fitting, which allows you to easily create any type of seatbelt and fit it automatically around your occupant. Seat squash, we have tools there that allow you to squash the seat that you're sitting the dummy in. And then seatbelt and seat coupling, so you can move your seat around, couple the occupant to that seat, and the dummy will move with the seat as you're moving it. And then we have dummy positioning. So you can position your dummy within Primer, but you can also use Primer to set up an LS-DYNA pre-simulation analysis to position your dummy model. Before getting into pre-simulation analyses, I want to talk a little bit about dummy positioning and dummy trees. So dummy positioning involves using a dummy tree. So what is a dummy tree? A dummy tree is simply a collection of ordinary nodes, elements, materials, etc., but with the extra property that a star dummy definition has been created for it. This is a special set of additional data which defines how the parts of the dummy are connected together and in what order. The key points are a dummy is made up of a series of assemblies, each of which contain one or more parts and node sets. For the purposes of positioning, each assembly is assumed to move as a rigid body, although its definition may include both rigid and deformable components for the purpose of analysis. Assemblies are connected together in a hierarchy in which a parent and child relationship are strictly defined. For example, the pelvis is parent to the upper leg, which in turn is parent to the lower leg, which is parent to the foot, and so on. So thus, the foot is a child of the lower leg and a great-grandchild of the pelvis. Generalized stiffness definitions between assemblies define the local axis a child may rotate about with respect to its parent. The root part, generally the lower torso or pelvis, is assumed to rotate around the dummy H point. So dummies may constitute individual models or may be part of a complete structural model. It makes no difference. The star dummy definition is appended to the end of the file after the star end keyword, and so is ignored by the analysis code LS-DYNA, but can be read by Primer. So here we have a child dummy model, which has a dummy tree defined. As you can see, with the tree defined, it's very easy to either specify the rotation angles of the various assemblies by typing them in, or to interactively click and move the assemblies to the desired target position. So here you can see I'm clicking on the arms and hands to move them into position. I can also do the same thing with the lower legs and the feet. So I will now talk you through the simulation-based dummy positioning tools available within Primer. Pre-simulation-based dummy positioning has become the norm. This is when you run an analysis in LS-DYNA that's sole purpose is to position the dummy. So why would you use a simulation to position a dummy rather than just move the dummy assemblies around in Primer as shown in the previous example? Well, one of the main reasons is you can avoid initial penetrations that can occur between assemblies during positioning. Remember, the assemblies move as rigid bodies. Also during the positioning analysis, the simulation takes into account all the internal material properties and contacts that are defined in the occupant and seat model. So this makes simulation-based positioning much more realistic. As dummy models become more complex and contain more detail, as with human body models, simulation-based positioning is required. Here is a cut section through the pelvis of a dummy model during a positioning simulation. You can see the amount of interaction and deformation involved between the various parts of the model. And this reinforces why a simulation-based positioning analysis is often the way to go. The functionality for creating a pre-simulation dummy positioning analysis can be accessed in the Dummy and Seatsquash tool in Oasys Primer. So this flow diagram outlines the process of positioning, but we'll cover this in detail over the next few slides. So the process is thus. You read your dummy model into Primer along with the dummy tree. You then use Primer to specify your target position. Once the dummy is in the desired position, Primer will automatically calculate cables required to pull the dummy into that position in an LS-DYNA simulation. LS-DYNA will write a DYNA-IN output file at the end of the analysis. The DYNA-IN file contains the updated nodal coordinates and initial stresses of the final position. These can be imported back into Primer. So here we have two examples of positioning analyses. The first one is a one-stage analysis. This means we have just created one set of cables to pull the dummy into position. You can see here that the dummy is moved into the seat, squashing the seat foam. At the same time, the arms and legs are moved into the final position. On the right, we have a two-stage positioning analysis. Here we have two sets of cables in series. The dummy starts above the seat, and the first stage is to move the arms and legs into position. The second stage is to move the whole dummy down into the seat. You're not just limited to two stages though. You can have any number of stages in one analysis. Consider this example. The dummy starts off above the seat. The next stage is to move the dummy into the seat, as with the previous example. Next, we move the arms up to be either side of, but not on, the steering wheel. Then we move the hands onto the steering wheel as a separate step. You can imagine it may not be possible to realistically position the hands onto the steering wheel in one movement. The next stage is to move the feet into position onto the pedals. Now at this stage, we have positioned the dummy. We have a final position. So we can specify to write a DYNA-IN file containing the updated nodal coordinates. However, if we wish, we can continue the analysis and move the dummy into another position. For example, having the hands in a slightly different position on the steering wheel. So you don't have to go through the whole analysis again. You can just pick up from the previous position and continue the analysis to a new position. So here we're looking at the results animation from a multi-stage analysis. You can see we have many cables in series for the various stages. When we reach the first final position, we write a DYNA-IN file that contains our updated coordinates. But then we continue the analysis to another position and produce another DYNA-in file. So I'd like to move on now to talk about how the tools I've talked about so far can be used to position human body models. So as you'll know, human body models are biofidelic computational models of the human body designed to replicate biomechanics and kinematics in a variety of scenarios. We've had growing interest from our clients to support human body model positioning in Oasys Primer. So what we have done is develop primer dummy trees for various human body models. These are similar to the previous dummy models that you've seen in this presentation. The human body model is separated into assemblies. These assemblies are then connected together into a hierarchy with a parent and child relationship, and the joints between the assemblies have appropriate properties and stop angles to ensure realistic articulation of joints. Now, an important point to note here is we are not modifying the original dummy model in any way. The dummy tree is additional information that sits on top of the original dummy model and is used only for positioning. So I'll now talk through the various steps for creating a simulation-based dummy positioning analysis for human body models in Oasys Primer. The first step is to add the dummy tree to your human body model. So, dummy trees are now available for various GHBMC and THUMS human body models. As mentioned on previous slides, the trees contain information on the various sections of the dummy and how they can move relative to each other. And this information is used by Primer to allow realistic movement and positioning of the dummy. You simply add the dummy tree as a new include file to your model to use the positioning tools within Primer. Note the tree has to be added to the original human body model you received from your supplier. The tree contains references to positions and entity labels in the original models, so the original model and position is required for it to work. However, after the tree include file has been added, the model can be freely oriented and renumbered, and the tree will automatically be updated within Primer to account for those changes. The next step is optional but very much recommended, and that's to read in a Primer properties file. So alongside the dummy trees, we've also created Primer properties files for the supported human body models. Now these are files that set the color, transparency, and visibility status of the various parts of the human body model that make it easier to see the relevant parts of the dummy when positioning. So here we have an example of how to read and apply a properties file to your human body model. The example here is the GHBMC Occupant model. So you go down to the bottom of Primer and hover over the Save P button. This is where you can save properties files and click on the Options pop-up. On this panel, you can save properties, but you can also import properties from a file. So if I click on Import from a file, you can specify the file that we give out with the dummy tree for the particular model. So if I read that file in, click OK, that is now applied to the model. And as you can see, the visual attributes have been changed, so you can just see the skeleton and the outer skin in a transparent mode. This makes it much easier to see what's going on and aids you when positioning your dummy model within Primer. I'd just like to highlight the range of movement and detail that is now available after having included the dummy tree. Here, we're just looking at the skeleton of the GHBMC model, so you can visualize what's going on internally when using the positioning tools. As previously mentioned, the dummy trees define child-parent assemblies and joint definitions based on anthropometric data. This allows assemblies to be realistically articulated in tandem. You can see in this model, we have defined many assemblies in the spine. Everything is connected in a realistic way. You can see here, when moving the head, the spine moves, And when moving the arms, the shoulder joints move also. You can also see that realistic stop angles have been added to ensure appropriate relative movement between the various assemblies. After reading in the properties file, it's recommended to globally move the dummy to the desired starting position and save the model at that position. In this example, let's say the starting position is in the seat. You can set up analyses that combine dummy movement and positioning and seat squashing, but in this case, we'll just set up a simple dummy positioning analysis. To globally move the dummy, go to Tools, Safety, Dummies, and then select Position. Here, you can use the Translate, Rotate, and Scale options to globally orient the dummy. Also, you can use Set H Point to specify a starting position. I'm going to use that method here. Simply type in the H point that you want, and Primer will globally move the whole dummy model. It's now recommended to write the model out using Model Write to save your starting position. The next step is to specify the analysis type. There are various positioning analysis types that are available within Primer. The setup of these analyses is in Tools, Safety, Dummy and Seatsquash. Here we have three options. The first is the analysis type. Here we can choose Dummy or Dummy and Seat. The Dummy and Seat option links in with Primer's Seatsquash tool. This includes extra functionality to help rigidify parts of the model, such as the seat base, as part of the analysis. In this example, we're just going to use the Dummy option. Note you can use the Dummy option to move the dummy into the seat as well, if you want the seat and dummy to remain fully deformable throughout the analysis. There are two cable types, force-based and displacement-based. The force-based cables are an older method. It's very much recommended that you use the displacement-based cables. Next, you specify the number of stages. If you want to move the dummy into position in one movement, you can choose one stage positioning. If you want to move in 2 stages, you can choose that option. Or we have a general multi-stage positioning option. We're going to use that option in this example. Note displacement-based cables are required for multiple stage analysis. Once you're happy with the settings, click Next. The next step is to set up information required for simulation-based positioning. Simulation-based positioning requires certain information to be specified. For example, for cables that are created to pull the dummy into position during the analysis, Primer needs to know where to attach the cables. Various other settings and properties also need to be defined. The panel that is now opened in the bottom right allows you to change these settings. Note their defaults contained within the dummy tree. You can see here that 3 nodes per assembly have been predefined to attach positioning cables to. You can change these if you wish, or reduce the number of cables that will be created, but it is recommended, at least in the first instance, to use these defaults. If you click Next on this panel, you can see a series of settings which also have defaults. More information on these settings can be found in the Primer manual. Again, it is recommended to retain the defaults when setting up analyses in the first instance. Here, for example, are values for cable stiffness and damping used in the positioning analysis. You may want to modify these if you see instability or noise in your analysis. On the final panel, click Finish to go to the next stage. The next step is to specify your target positions. First, we want to record our starting position. We've already done this earlier in the process, so here we just click Next. The next panel is where we define our intermediate stages. Here we can specify any number of intermediate stages. Let's specify one stage where we move the feet. We use the standard primer dummy positioning tools available in the bottom right-hand panel to do this. Here, you can specify certain specific rotation angles, move points to specific positions, choose save positions, or interactively move the dummy. Here, we will interactively move the dummy. As you can see, I can just use my mouse to click on the foot and move it into position. I can use the different mouse buttons to fine-tune the position and the relative rotation angles between the assemblies. Once I'm happy with my position, I save that on the panel. Now let's say I want to add a new stage, this time moving the hands up onto the steering wheel. I can use the same tools to do this. Once again, using all the mouse buttons to fine-tune the position of the hands on the steering wheel. Again, once I'm happy, I can save this position. Note you can go back and modify these positions at any stage. Finally, let's add a third stage where we move the head. Again, once happy, save the position. Note on this panel, you can specify the analysis time for each stage and specify if you would like a DYNA-IN file written, which contains the updated coordinates, at the end of each stage. In reality, you may combine the movements I've shown here into one stage to save analysis time. The legs can move at the same time as the arms, but I've separated them here to demonstrate the multi-stage functionality. Click Next to go to the next stage to define the final position. Here we specify the final position we want the dummy to end up in. So you do not define the final position in the previous panel. That is just for intermediate stages. So here I will move the hands into a slightly different position on the steering wheel. This means I can produce multiple positions and DYNA-IN files from one analysis. Once happy, save that final position. Note you can create multiple final positions here if you wish. This means that Primer will create multiple analysis models. Generally though, you will only be specifying one final position at this stage. Now we have specified all the required information, we want to create the model. So when we click Next here, we can create the positioning analysis model. So we click Next and then we click on Create Model. So what Primer is doing now is creating all the cables required to pull the dummy into the target positions with the correct properties to match the timings and settings specified in the previous steps. It is also creating all the required control cards for the analysis, and this includes all the cards required to produce the DYNA-IN files at the times specified. So once complete, you can see that Primer has created a new model. The original model has not been modified. You can see the cables that have been created to pull the dummy into position. So here you can see the new model that's been created within Primer. You can now write this model out and run it in LS-DYNA. Now, you should not include the dummy tree include file in the LS-DYNA analysis. This is encrypted and LS-DYNA will not recognize the information included. Okay, so now let's have a look at the output results. So here we have the output results from a multi-stage positioning analysis. The first stage is to move the feet into position. The second is to move the hands into position, and then the head. We also have a stage at the end where we move the hands, feet, and head into a new position within the same analysis. And here we have an example of the THUMS model moving down into a seat. So we now want to import the updated nodal coordinates from the DYNA-IN file back into your original model. So here we have the original model read back into Primer. We now want to read in the DYNA-IN file from a positioning analysis and update the nodal coordinates. To do this, you go to Tools, Node Import, and we select the DYNA-IN file that we want to read in. We then click Next. So now what Primer is doing is reading the contents of the DYNA-IN file into a separate model. Once it's done this, we'll then get the option to copy information from that second model back into the main model. So now we just select which information we want to copy across. So we'll just select all parts in the keyword file. And here we get a few choices for copying across initial stresses, creating initial form reference geometries, and so on. For this example, we'll just import the new nodal coordinates. So if we click Apply, the original model will now be updated with those updated nodal coordinates for the final position. So I'll just show you the new model compared to the original model. So here we go. So here is the original model, and here's the updated model where the arms and legs have been moved into position. So to wrap up, we have developed human body model dummy trees for the following THUMS and GHBMC models. We have the GHBMC version 5 and 5.1 Occupant 50th percentile. We have THUMS version 4, pedestrian 5th, 50th, 95th, and 6-year-old, and the Occupant 50th percentile. And then THUMS version 5, the pedestrian 50th. Now, alongside the dummy tree include file that you include with your dummy model, we also give out a positioning guide that talks you through the process of how to set up these types of pre-simulation positioning analysis using Primer, and also the properties file that applies visual attributes that makes it much easier to visualize the dummy model when positioning. So the dummy trees are available upon request without charge from your local Oasys distributor or by emailing us directly at dyna.support@arup.com. So to summarize, the Oasys LS-DYNA environment can provide a complete simulation solution for occupant safety, including the use of human body models. Realistic articulation and positioning of human body models can be achieved using Oasys Primer, ready for simulation-based positioning analysis in LS-DYNA. And Primer-specific dummy trees are now available for industry-leading THUMS and GHBMC family of models. And more models will be added in the future. So that brings me to the end of my presentation today. So thank you very much for your attention.